Hello, and welcome to the 12th episode of Cycles Podcast. Today we have Bret Fisher, who is a Docker captain and also a Udemy instructor. Bret, it'd be great for you to introduce yourself and share a little bit about what your day-to-day looks like, what you're working on with our audience.
Hi, Jake. Glad for being here. This is our second time hanging out. So I'm a Docker captain. You mentioned that. That just means I'm a kind of a community leader, volunteer to talk about all things containers. And I'm also a consultant and a trainer. So most of my week is usually working on my courses, which I think we're working on our 5th now course on Kubernetes, Docker, all the container topics on Udemy. And then I do a weekly live show on YouTube called DevOps and Docker. And then I do a podcast out of that. And I have a nice little team that we've built. I'm also a multiple company founder over the last 20 years. So this is like our 6th attempt at something that works, and it actually works this time. So we have a nice little company that we focus on the training aspect and videos. I think we've made over 600 videos or something at this point. So yeah, that's my week.
Yeah, and so as you already alluded to, one of the and maybe a number of people who are watching this have seen, but I was on your show back in January of this year, and we had spent quite a bit of time diving into a demo cycle at the time. But my hope with bringing you onto our show at this at the moment is being able to dive into not just the technologies around containers is always an interesting thing to dive into, but more of potentially the business case and the value behind this so not being in the weeds of the tech, but more of the how has this tech changed how businesses are operating, what have we done wrong, what have we done wrong in the industry, what have we done right in the industry, and more of a high level, just kind of fundamental perspective and looking at containers as a whole as opposed to the individual technologies that make it up.
Right.
And so I know that you have your show. You have a lot of people that are coming onto your show to show off really cool technologies and things. But besides your show, I know that you also do a lot of consulting. Can you dive into that briefly?
Yeah. Well, this all started, shortly after Docker was invented, and it, we're basically 9 years ago this month, and at least in March. That's when Docker was sort of announced to the world. And it's amazing. I think back then I was thinking, this is at least a 10-year evolution that we're about to enter into. So my story kind of goes around 2014, 2015. I was in a tech startup that I co-created, and we were using Docker to solve a lot of problems, even back then in its infancy. And it was really all about speed. So when you hear me talking about containers a lot, I'm really focused about the speed of business objectives. And that's really, if you look back over the 30 or 40 years, I have an increasing amount of gray in my beard. So I've done these technology evolution pivots, I guess you could say, many times before. In the 90s, we were going from mainframe to PC. Then we went about a decade later, we went from PC to virtualization, or we went from a hardware-based single OS per piece of hardware to a mini OS per piece of hardware virtualization world, and was a part of a big government agency that sort of was I was leading the charge on virtualization. I was very passionate about that change, but everyone thought it was heresy, right? Everyone thought it was crazy to put all these OSs on one machine. Won't it be really slow? If you fast forward a few years later, we're now outsourcing that hardware responsibility to the cloud. The cloud is invented, so that's a huge shift. And we're kind of in that same shift now with moving our workloads into it's not a layer of virtualization, but it's an encapsulation or a layer of isolation a lot of times that allows us, again, more business speed, the velocity of deploying code, updating code, reverting to old versions of code because we have to roll back, like you name it. Containers have basically improved or sped up those processes. And I think that's what got me motivated in 14 and 15 when I was first starting to use it. I pivoted my entire career at that point, which I've never done for a single technology. And I decided this is such a huge change. I'm going to do nothing but this now. I'm only going to consult on container implementations and container optimization solutions and all that. I'm only going to talk about it, and I'm now going to start making courses about it. Eventually, that happened like a year later. So, and that's, here we are 5, 6 years, 7 years later, and that's exactly what I'm still doing. Is the container revolution, I think, is something that's underplayed a little bit. We're all enamored, right, by that latest tool that somebody's announced, but really at the core of all this is the idea that we're taking our workloads and isolating them, not in a virtualization layer, but in simply an OS construct that Linux and Windows happen to support. So I think that idea still holds a lot of weight today, and I'm excited for the next decade of how we're going to even make it better and faster. So,
And a lot of what you just said resonates with me, especially, you pivoted your entire career around the containers. And I'm thinking back to right around that same time frame. It was late 2014, early 2015. Cycle was in its early stages at that point, but Cycle wasn't a container platform. We were building, I'm sure you're familiar with Squarespace, these website builder type frameworks, right? And so we'd spent years, well, I'd spent years building a dev shop where we were building websites and things like that, building early SaaS products for other companies. But as we kept building these SaaS products for companies, we had to always redo so many of these infrastructure components every single time we started the new project when we had that dev shop, that it was there was a point where it was so obvious that we need to build something to make this easier. And so we had started building Cycle, and I didn't know what containers were at the time. This was right around that start of that being a thing. And so we were probably about a year and a half-ish into building Cycle, and it was a platform that at the time was built in PHP, right? Like, I mean, we were pushing PHP to do things that PHP shouldn't be doing, right?
Right.
Like, we're writing like TCP layers in PHP. Like, it was the stupidest idea, but at the time it seemed smart. But the issue that we kept returning to as we were building that out was the idea that as we kept building out this framework, we had so many of these companies that we were working with that kept saying, hey, we have another dev team somewhere else that wants to be able to pull in code to this framework and things like that. And the hardest part for us was, how do we allow people to run third-party code inside of this existing framework without them having to know exactly how we structured the language, or not structured language,
right,
but how our use of PHP and things like that. And so we were sitting in our office at the time. It was me and I think 4 developers at the time. We were sitting there, and we came across a tweet on Twitter, obviously, and it was about DockerCon. And this was, I guess, DockerCon. I guess it would have been DockerCon 2014, or it was 2014 or 2015, one of those 2 years. And we were sitting there watching it. We had it on the screen in our office, and next thing you know, they start diving in, and there was a demo that they did about containers. And it was that day that we're sitting there watching this that we went back. I remember I stood up, I went over to the whiteboard, I erased everything that we did, and we said, we're changing the company today. So as you talk about pivoting your career, that one day of being introduced to containers was a pivot to the entire thing that is Cycle today, where we had pivoted from we're going to be a website platform to we're going to be a container orchestration platform. And so I think I guess getting back to the point here of the like what you already said of the revolution of containers, the adoption of containers sometimes is lost, amongst so many of these new technologies and things that we don't realize, or maybe we forget or gloss over how much it changed how businesses and developers operate today. And so just really neat that it had, that single year impacted both of our careers so much in that capacity. But
and I think that's the challenge that's when I draw this out, I start with the 70s and 80s, and I talk about major evolutions in infrastructure, because that's kind of what Docker is to me, right? Like, it is a software idea. It doesn't necessarily directly talk to hardware, but it is an abstraction layer that we have all created, and it is it creates technology momentum. And so when I think of these major evolutions of, like I said before, like mainframe to PC, PC to virtualization to the cloud to containers, Like none of these things really have anything directly in common with each other. But the idea is that at every point, it was always about speed. I mean, we obsess over computer CPU gigahertz nowadays. Maybe not near as much as we did in the 2000s, where it was like all about single processor reaching the limit of thermal dynamics. But all of those things were always about speed. But there's more than just CPU and memory speed, right? It's really at the end of the day, it's about the speed of business. And so these ideas, if they're not implemented properly, what's funny is about every one of these evolutions, if you did it wrong, it actually hurt the company. Like it would, if it didn't have clear business objectives and goals and metrics, which is something I talk about a lot in the DevOps world, is metrics. If you're not measuring the performance of the teams and the organization in terms of from the time the company has an idea to the time that software is in front of customers, like that is the DevOps landscape, right? That's why we had that huge infinity symbol on all the logos of DevOps things, is that that's the continual loop of infinity that we're all dealing with. And inside that somewhere is the idea that we need to take the code, get it tested, get it packaged up into an artifact that's exactly the same on every system we want to run it on, and then get it on those systems to run as fast as possible. And containers is actually the fastest way we have come up with to do that. And people have to say, well, what about serverless? Well, I'm thinking, well, serverless, functions as a service, those are just running in containers too. So you're just running it in someone else's container, not your own. And it's not really anything different other than just you're changing the language a little bit and breaking things down to even smaller than microservices. But often I'll also get the question, like, what is the future of containers? And I don't think anyone's come up with anything other than just iterating on what we're doing yet. And we're just making containers faster to build, smaller, more secure, isolating things better, better secure defaults. Like that seems to be the theme of a lot of the tools and technologies and that we're all using, and not like we're going to have to undo containers and go to this whole new idea. I don't see that happening anytime soon. I think really the idea of isolating a workload on an operating system is really kind of, if you think about our phones, our Macs and PCs, like everything we're using is all improving that technology. With every update, there's always something about isolation, security updates that don't affect the entire system, but just one little part. And that's really where we came from. And not to go down too far that rabbit hole, but if you look back when we started the PC revolution, the idea was actually that the hardware got smaller and cheaper, and that the operating system was was all encompassing of that hardware. And so the idea of virtualizing in that hardware, or rather isolating things inside the OS, that was actually a mainframe concept back in the Unix days. But once we got to PCs, we kind of undid all that. We said, well, no. The hardware is where we isolate now. Like, it's super cheap. It's not $1 million like a mainframe is, so we can buy these super cheap pieces of hardware, and then we'll just isolate at the layers of hardware. And then we got smaller and smaller computers, cheaper and cheaper servers that were going faster all the time. But then we realized the OS as a boundary and the hardware as a boundary is actually a really poor way to do things from a speed standpoint. So if you remember 20 years ago, we were all struggling with, hey, in order to do this new idea, we had this business idea, we got to do something, we need servers for that. Well, now you've got an 8-week lead time if you're lucky, because you got to buy the hardware, wait for it to show up, wait for someone to implement that, get the operating system, the backups, the monitoring, all the things planned out, and then you can finally put your app on it, right? So that was fast then, because mainframes took a year to buy. So PCs were really fast to acquire even though it was 8 weeks. But we always are pushing the envelope, right? We want to implement ideas at the speed of human minds. Basically, if I think it, I want it to happen. So the PC grew into this idea of we need to break that PC down and put more things on it and isolate them better. This is how we came up with virtualization. We virtualized the OS, and then eventually, you and I were in that world of, okay, I'm now one person and I'm managing 1,000 OSs, and I can't manage all the different operating systems, their patching, their updates, the replacement of those OSs when they break or they go out of warranty or whatever. And that became the huge nightmare that we were actually, we implemented virtualization as a solution, then we created our own new problem. And then containers came, or the cloud came really first, but it was there to say, hey, we've got your problem, we got your back, we already bought all the hardware, we're going to make it faster for you because that's ready to go, you can do it in minutes. And then we realized we're still underutilizing the hardware, we're still managing thousands of operating systems. how can we avoid all that? And I think that's really the world of the container, which you were clearly already working on a different idea of what that might look like. Like, let's isolate workloads in a consistent manner. How do you do that in PHP was your original idea, but now you're just saying, how do we do that in containers? So that's really all the same stuff, right? We all kind of arrived around that same time frame, 2010 to 2015. That was kind of the idea of, let's isolate inside the OS rather than the OS itself.
Yeah, and like you're talking about isolation, like obviously the speed that containers has brought developers has been hugely fundamental, but the consistency as well and the problems that you solve there with the isolation from that component is also just so widely valuable. And I think back to again around 2010, where so many people are encountering these problems back with shared hosting, where someone would throw a cPanel on a server, and next thing you know, you'd have how many dozen unrelated accounts sitting on that same server, and then you'd have a customer reach out and say, well, right now we're on PHP version 4.2, we need to go to version 4.3, and you're like, well, that means I have to update it for the entire server. And I know there were like some workarounds right. where you could start to
right.
kind of segment that, but it was one of those things where it was when you were isolating everything from a hardware perspective, as you're mentioning, it's so hard to be able to run slightly different variations of software on the same machine, whether maybe one application needs a slightly older version of Python or PHP, whatever the underlying language is. It was so hard to do that in a responsible and easy to maintain way. And right around the time that, in Cycle's case, that we decided to pivot the platform fully into containers, I remember we had a customer that we were working with, again, back when we were a dev shop, or not Cycle being a dev shop, but the company I was building at the time was a dev shop. And there's one of our clients that we were scaling up their infrastructure. And this client had, they had chosen that they wanted to use DigitalOcean for deploying things. And I don't remember exactly which dependency the issue was with now, but we had said, and I don't remember like what version of Ubuntu was back in 2014. Right. Someone knows. I have no idea what it is. We'll just say it was Ubuntu
1404. I'm going to guess 1404.
Okay, we'll go 1404. Right. So I guess my point though is we said, hey, we want to make sure that this is not all in just one geographic region. We want to deploy these across different DigitalOcean data centers on the chance that something goes wrong. We just want to have that reliability or that availability there being in multiple regions, right? And so I remember we were deploying servers and we had chosen Ubuntu 14.04 or whatever the right version was at the time. I don't remember. And we had deployed five or six servers at that point. And then we realized, we had encountered this really weird bug, and it took us like 5 days to figure it out. And it turned out that even though we had chosen the same base operating system, DigitalOcean had slightly different variations in their operating system images for each region. And we did not expect that, right? So there was a version of, I believe it was like OpenSSL or something like that, that was slightly different on one region versus another. And
maybe due to encryption laws or something, maybe.
I don't remember what it was, but whatever it was, that variation in that version was causing an issue for us. And so it was one of those things like that was right around that same time that we were discovering containers. And that was kind of one of the epiphanies that we had of, wow, wait, we can build applications and not have to rely. So yeah, I mean, yes, the speed of being able to take that code and get it deployed, but also the speed of debugging, where if we know that it works today, we're not going to have to debug it if it's running at two different servers in two different regions or whatever that is. So the speed of debugging has been obviously a huge value add to containers as well.
And a lot of times we're not, back then it was also hard to track all this stuff, right? Like, so what are you changing on the host that's affecting all those, change root, or whatever you're doing to isolate back before containers, right? We were doing concepts of isolation, but they were all like one-offs and they weren't really consistent. They certainly didn't have all the dependencies, right? So you still did a lot of shared dependencies and whatnot, especially because you were trying to save space. If you're a fancy hosting company, right, you'd mount in system utilities like OpenSSL for the user, but then they could run stuff on top of that. So it was funny how we had some of these ideas, but none of them were really truly complete in a full isolation pattern, including their own IP address, right? That their operating system file system is blank by default, which is essentially what most people don't realize is when you can actually start a container from something called scratch. And that scratch means truly empty. Not a single file is in my container. And you have an IP address, you have a file system, you have memory and CPU, but you have no files until you start putting them in the container images. And we do see kind of see that trend now, especially with all these newer languages, right? You talk about PHP. And so if we can go down that language rabbit hole for a second, one of my soapbox moments a lot of times when I'm talking to people that often say, hey, Brett, you're in this container stuff. Like, what's the right language? And of course, that's a horrible question because there is no right language, right? It depends on people's expertise, what you're trying to go for, what type of app you're building, all that stuff. And that's why I think what we're seeing a lot of times now is that at a fundamental level, in the 90s when Linux and FreeBSD or any of the BSDs or any of these concepts on Unix were all being invented, and of course we had Windows at the time, it was a lot about shared components, right? If you think about, like, we all had shared DLLs on Windows and we all had shared binary libraries, and we all had the same Python version on Linux, and so these were all about shared components. And that was a time where the bandwidth was limited, so we didn't want to have to install things. Of course, in the 90s and early 2000s, we were installing things in CDs and floppies, but it was all about, like, we didn't have enough space on the hard drives. Hard drives were really expensive, and we didn't have a lot of space to get new things there in an easy way with floppy CDs, USB drives, and slow internet. So we needed shared components. But one of the interesting trends I also see now is when people start deciding on languages, is we see that all the leading edge tech companies are all moving to languages like Golang and Rust. And not to get into like why those languages exist or which one's better or whatever, but the single thing that's unique about them is that they're going back to statically compiled binaries, which means when you ship your code, you're shipping a single binary with everything, including the shared libraries in it, which sounds wasteful, right? It sounds like shipping a 50 meg binary doesn't sound near as optimized as distributed little Python binaries and libraries everywhere, right? That sounds better. But in fact, today we got to look at our problems, right? Today our problems aren't disk space or memory space or internet bandwidth to get stuff downloaded to our server, right? Those are no longer the problems. We've kind of solved those more or less. Disk space is one of the cheapest resources you can get on the internet. So we don't care so much about shared components anymore. So it's funny because if you go read about these things on the internet, often you'll get 15-year-old answers like, should I build statically compiled binary code like C used to do, right? C++ and stuff. And you'll see people talk about, no, you don't want that model. You want this shared component model. And we all want to use apt-get to go get our dependencies and have shared dependencies amongst everything. But those were different motivations. Those were different times solving different problems. And so it's just like containers, right? We were all trying to learn containers. The first time I tried to learn it, I did not understand it. I actually failed in my first attempt to implement it and had to come back 6 months later and revisit even the concept of it because it didn't really make sense to me when I first tried it. And we're doing the same thing now with languages where we're realizing that there's new problems, and those problems are the speed of business, the speed of ideas. I need to be able to ship my stuff faster and be able to test and deploy it in an isolated way even faster and multiple updates a day, and this whole trend of just shipping constantly all the time. And that actually works a lot better and is a lot easier when you can build a single file and ship a single file. So if you're doing it 10 times a day, shipping 10,000 files 10 times a day turns out to not be super optimistic. And shipping a couple of files or a single file in a statically compiled binary is actually the trend. So again, these are all really, when you break it all down, why do we implement these new technologies? They will never catch on unless they're saving humans time. And at the end of the day, that's kind of what Cycle's trying to do, right? Saving humans time and trying to optimize the path from idea to it's now in front of customers. And let's go do that again 10 times a day.
Yeah,
So,
and I guess so yeah. That the whole goal behind Cycle, as you mentioned, is focusing on that simplicity. Our idea being that most people don't need a lot of complexity to get things online. How many companies out there are just building SaaS offerings where they don't need to have their hands into a whole bunch of different things that maybe some of these like bigger healthcare companies might need their involvement in. Like there's somewhere in the middle of the market where there's these companies that just need a base foundation to go off of. But going back to the point that you made about languages, So I think I mentioned on your show. I don't remember, but I think I'd mentioned that Cycle was built entirely in Golang now. Like after we switched from after we realized the value of
Right.
containers, we're like, all right, PHP is gone. We're going to switch over to Golang. But it's really interesting, kind of bringing all these things together now. And I know that we're getting a little into the weeds, but the developers watching this will appreciate that. Is that I don't know if you write Golang yourself. But one of the really interesting things that has come out recently is the whole embed functionality, where you can not only just have that static binary, but now you can, at compile time, reference like outside files that should need to be embedded in that binary at build time as well. So then you have,
Right.
you can have a JPEG. I don't know why you would, but you could have a JPEG, literally embedded in that same binary at build time, and it's really neat as we start like I like one of the it starts getting my mind wondering like, okay, as time goes on, like obviously you and I both agree on the value of containers, but as time goes on, are we going to end up being in a position where, and I know that they're trying to solve this with WebAssembly, but where we end up in a position where instead of running, like instead of using like all this extra, React and things to have like client side stuff running in your browser, where we're shipping full blown, binaries as web applications that you just hit from a browser and it just runs in your browser, but it's native Golang or whatever,
Yeah.
the underlying technology is.
Yeah,
And
and I think that that's the trend. I think that, you know, the way that WebAssembly is going to win is if everything I'm doing doesn't have to change. And this is kind of what happened. This is the magic of Docker, is that nothing had to change other than one step at the initial idea of Docker. It was don't rewrite your programs, don't design your applications differently. You just take them and you encapsulate them in our package format, right? And then it can go everywhere in the exact same way and repeat 1,000 times over. And that's why, like, for example, serverless is to me always going to be something that it's either all or nothing, and it's always going to have to be greenfield written. Like you're going to have to start from scratch with that stuff because it's a new paradigm of how you write the code. Whereas Docker said, no, we're bringing everything with us. You got a 1980s 5 app that still runs on Windows, we can do that for you, right? You got a Linux app that ran in 1997, we can bring that forward for you. So that's kind of what I think really caught on with containers was it didn't exclude anyone. It was very open. And I think that WebAssembly can do the same thing if I can keep writing in everything I'm doing. And then if I want it to be in a browser, I just run one utility, one command, and outputs this single binary or whatever it might end up being, right? Because I'm not a WebAssembly expert. But I think if that was what was really happening and what was going on, then I think it becomes a no-brainer because at the end of the day, what makes more sense? We're constantly moving all these files around. You and I are, when we're building our apps, we're never just building our own app. We're building all these dependencies that come from everyone else in the world, And so if I go scan, let's say, the typical Node.js app, and I go scan a container of everything that is needed for that app to work, it's probably 100,000 files just for that one web app. Does it make sense to do that or ship one file, right? It just, it doesn't. At the end of the day, a lot of the times the performance and the problems and the just collaborating together as engineers, a lot of these things all come down to the assumptions of the language and the assumptions of the frameworks on top of that language. And I think when we look at older languages, I love Node. I was a huge fan of Node, and I was very early on adopting like 0.6, which I think was the first release that I actually ran in production on my own apps. And so, 2011 timeframe, NPM was a huge game changer because, again, NPM being a package manager, it's a low level, but it's a package manager. And originally it was just for JavaScript, but now all kinds of things come in NPM, and it's sort of almost as universal as Docker, but not quite. So the thing about NPM was it was all about using other people's code. And it was a huge differentiator in 2010, 2011, when we didn't really have that everywhere. And it also, of course, worked in web browser, not just in servers. So it changed the game and sort of upped the level of package management and distributed application code by us all being able to pull in everyone else's stuff. I remember shifting from .NET. We took our app in .NET and did what you're never supposed to do in a startup, and we completely redeveloped it in Node.js, and we lowered the lines of code by over 50%. And we did that because we were moving from .NET, which was traditionally buy it or build it. You have to, buy shared components in that world. Back in the day, there wasn't really any open source. There wasn't much open source in .NET. I think it was all like Source Foundry or something like that, or build it. So you were usually building it, and you had to implement date and time format, things that would automate that, right? So you did all these low-level things as a team, But npm changed that. It wasn't the only package manager at the time that did this, but it was becoming the best very quickly because I could just put in a one line command or one line in my code, and boom, I have all these things over and over again. And there was thousands, and then tens of thousands, then 100,000s, and now there's millions of these packages. And you and I are now seeing the future of, well, that idea for package management is actually now burdensome because we're now all carrying around hundreds of thousands of files, and sometimes in some of these Node.js apps, there's gigs worth of dependencies just to make your app work. And I think we're realizing that that inhibits business speed, that slows down the speed at which a business can operate. And we're always trying to solve more of these problems in this speed loop. And one of them now is too much complexity in the dependencies, too many layers of dependencies. I need now apt and yum dependencies, and then I need npm and Ruby dependencies on top of that, and then I need front end dependencies, and I have like 5 dependency package managers, right? But if you can get to these newer languages that they work in front end and back end, they work everywhere, as well as being able to isolate down to just very discrete packages, it tends to, larger teams are finding that that's a much easier way to operate. So it's funny because it's not really about the components of the language or necessarily the features of the language, like you said. It's not always about that, which I think engineers sometimes really get into the geekiness of that, and they start talking about classes and just various functionality of the language. But I think at a much larger level, and of course there's always fashion in tech, so it's fashionable to be in these new languages. But when you move beyond that, if the team can do more faster with a new language or a different framework, that's always going to be the number one thing that pulls the team away from whatever they're doing.
Yeah, it's something that I mean, again, this is me coming back to being a Golang developer, but to your point, that's one of the things that I really appreciate about the Golang language and how it was built by the early team, is that it's a very opinionated language. There's not so many. There's only a few ways that you can really accomplish certain things, right? Like there's a very defined, normalized pattern of how you build Golang applications. And so as we talk about the speed of, even whether that's pulling in dependencies, whether that's standardization, like it's nice to be able to go from as a Golang developer to yes, I'm building cycle, but then to be able to go and look at code that someone else has written for a different project and not have to start making a whole bunch of guesses of how they approach things. It's just so opinionated, right? But the other thing with the dependencies, as we're talking about, that is always, that I think receives less attention than it should, is the vulnerabilities that can be found in dependencies. Like I think people just have this inherent trust of, oh, that's a widely used dependency, I can pull that into my code, and maybe my code's clean. I spent a lot of time focusing on the integrity of my code, but the second they pull in these dependencies, there's not much thought into, well, what vulnerabilities might exist in those dependencies. And if you're pulling in a dependency that has another as a dependency of a dependency of a dependency where you're 4 layers deep, how confident are you, or how sure are you that you have not just pulled some of these vulnerabilities into your code? And so it's one of my worries as the company continues, not just Cycle, but in general, as companies grow and as projects grow, what other things have they pulled into their critical applications that might have just been a single line to include, but now is going to lead to a large data breach or something like that down the road?
Yeah, and that's security is something that's near and dear to my heart, especially container security. Now that's all I talk about. But we're as an industry, we're getting much better at scanning dependencies, especially like if you're on GitHub, for example. Now, if you're storing your code on GitHub, they have dependency scanners called Dependabot that's built in to your code storage essentially. So you don't even have to. It wasn't that long ago that if we wanted to do something like that, you needed someone to implement a project to scan your code on a regular basis, and that took work and time. But now these, I'm talking about, actually just this week, I talked about them on my show that, actually it wasn't my show. I talked about at DockerCon's All Hands community event, which had thousands of people. It's like a mini DockerCon. And I talked about the pipeline of building your apps. Like what happens when you build your app? What are the different steps you should build? Where should you test it? How should you test it? How do you ship it to the servers? Like all those steps in the middle between committing code and it actually going to the server and the eventual deployments. what happens in the middle and what should be happening and what order should it happen in. That's a very gray area, I think, for a lot of people. That the internet's really good at giving us basics, but not really digging into examples and then varying degrees of examples. And so I kind of talked a lot about that. And one of my focuses was on CVE scanning, the vulnerabilities in your app and its dependencies. Mostly nowadays, those scanners, they really don't scan your code.
Yep.
That's a separate tool. But these code scanners that, these dependency scanners, we'll say Trivy and Sneak, and there's other ones, White Source. These all focus on your dependencies, right? And the nice thing is we all are at least defining our dependencies now, right? So even if you're in Python or Ruby or Go or Node.js or whatever, you've got these dependency files that are, it's pretty easy for the scanners to just go down that list, find the versions, and then compare it to the CVE database table that we all know about that lives, I think, in MITRE or whatever, and they show the list of vulnerabilities. Well, the older languages have this sort of inherent problem where they're standing on the shoulders of giants, and so that's a good thing. But the bad thing is that when you need all these nested layers of different languages in order to make your app work, there's an inherent risk that you can't avoid. So a great example of this, just a quick example, is I think it was last year, probably 2020, maybe 2021. In order to install Node.js in a container image, with the most popular way to do that with something called Node Source, it actually would install Python in order to install Node, which meant every container you had Node in technically had Python as well. And so we started having issues where Python vulnerabilities would show up in our container scans, but we never ran Python in the container. So we're all looking going, why do we have Python in here? We're using this particular Node image. And it turns out that the people that were installing Node just needed Python. So they assumed that they just installed it. They thought it was fine. Well, that was flagged as a bug. Eventually it got fixed. You no longer need Python to install Node. But this is one of those things where I think some of these newer languages, again, Golang, Rust, they're probably WebAssembly, but I don't know enough about it to know that whether or not that's confidently true. They don't assume all those things anymore. They don't assume that you have all these other tools on your system, because we all now know about containers and we know that we're trying to do things in isolation. You know, we've all even got these local package managers like Brew that install packages for us without us having to depend on the operating system to do it for us. So I think that trend is going to continue as we make more and more abstractions away from the OS itself and away from those base package managers like apt and yum. We're going to get to the point where your app is really just one language. That's the only language that you're probably going to see in your container. And even if it doesn't build it to a single binary or static binary or whatever, it's still only going to be that language, and there's nothing really else in there, right? Like no base utilities, no systems package manager, because your app builds and installs everything itself. That's not true today for so many languages. They still assume you have host packages installed, other dependency managers involved, and that level of complexity is just, quite frankly, unnecessary nowadays. So yeah.
Well, and I guess to as we begin to wrap up the conversation around specifically building apps and correlating it back to containers, I think one of the neatest things that came out with containers, it's a few years old now, but it's something that it's still amazing how I don't want to say little adopted it is, because I think that it's much more widely adopted now than it used to be, but it's just the multi-stage builds, where if you do need those other technologies during that build process, you can just drop them out before you get to your final build, right? So if you did need Python for building, I don't know, just something in your application, you have that freedom to pull that in. But once you have that final output, you can pull that out into the last stage of your container and just not care about it anymore. And I think that was such a valuable addition to containers that I think that people new to containers sometimes gloss over the why that is so important. I think that but yeah, and
yeah, I do that when I teach containers nowadays. Even when I assume people don't know containers, like people that are brand new to Docker itself, and at some point I'm always teaching them multi-stage, because I think it's an automatic evolution of, you're going to have different things at different times in your images, and let's design for that out of the gate. So I think that's sort of almost a default. That should be considered a default feature of any team using containers today. Is we need to use multi-stage in order to get our test and dev stuff out of our production images and just isolate our app and its true production dependencies. Because again, today a lot of teams, those package JSON files in Node.js apps. I'm kind of picking on Node.js because I know it the best. But you do an npm install and you're technically installing all the dev dependencies and production dependencies. And teams don't really fret about this too much until some security team person comes knocking on the door and saying, you got all these vulnerabilities in your application and its dependencies. And then the team realizes, oh, a lot of these are tools we don't even need in production. Why are we shipping them? And that, you and I couldn't have that conversation 10 years ago or 15 years ago. That conversation would have resulted in completely changing how we even installed the operating system, that we maybe couldn't even stop those packages from being on the server, So it truly became, those are the days really where we were depending all on Red Hat and Ubuntu heavily, or Canonical, the company behind it. We were depending on those companies to constantly update things because we were shipping them on every single server. We had to protect them, and we were waiting on them. If you remember coming from the Windows world, we had Patch Tuesday. Patch Tuesday was just once a month when Microsoft would bundle up all their security fixes into one big lump, because we were all waiting on them to fix everything in Windows all at the same time. And nowadays we're realizing that model is almost like a flawed approach, that maybe I'm not using IIS or a web server in my app. Why do I need to patch that? Why do I even have it installed? So I think that's what containers and multi-stage even more just give us that freedom to break all those things and isolate them up.
And that last point is a great segue into the next thing I kind of want to dive into, which is as an industry around containers, what have we done right and what have we done wrong?
Well, of course, being a container fanboy, containers are right.
Yeah.
We did that right.
Yep.
I think I wouldn't say it's wrong. I don't think we're doing anything wrong. I think if anything that's wrong in the industry, it's that we're not dedicating enough time in the teams for explicit learning and sort of workshopping with each other new ideas. I think that honestly, for me, the teams that I work with, that the culture is one of their largest challenges to container adoption, to orchestration adoption, to automation adoption, which I quite frankly, I think that's sort of the next revolution in our teams, is automating everything from the point that when I commit code, eventually everything, if you're not fully automated from that point forward, everything all the way to production deploy is being fully automated, then that is your future as a software team or as a software company that makes any software. That pipeline eventually has to be fully automated, or we're never going to get to the next point of speed, right? If we're going to try to go faster and faster without employing more humans, we need to automate. So containers in and of themselves, and that Docker build is technically a level of automation, right? That Docker build command was a huge step forward in speeding up our ability to package all our apps, all of its dependencies, and then isolate it in a single unit that we can do a Docker push pull and move it all around the internet, right? So that was a level of automation, but the teams often stop when it comes to that fully automated testing. We, so much testing, in fact, that we completely trust the robots. We don't need humans to validate our code anymore. We just need robots. Like that level of automation and testing, not a whole lot of teams have done that yet, right? That is a level of risk we haven't really consumed or been willing to do yet. And I think for a lot of teams, when you look at their pacing, that is where I see, if you want to call it wrong, that's where I see the wrong, is we're focused on tooling, but not focused on the culture of continual learning and continual automation. I mean, that DevOps background, automation is one of the core pillars, and continual learning and sharing your knowledge is also another core pillar of DevOps. And so I still think that DevOps itself, if you really focus on those core principles, they will eventually drive the team to these levels of change, rather than, oh, we're more excited about this particular tool, or we're going to change languages or frameworks. Like those give you little bumps. I don't think that you will see the huge shift once you've adopted containers to the next huge evolution in your team automation and your speed of business, until you, I think, really get the automation down and the continual learning.
Yeah, I mean, I would agree with that. I think it makes a lot of sense, and at the same time, you kind of, I guess, in line with that is the adoption of the, maybe let's just call it the adoption of the wrong tools, whether that's due to hype or whether that's due to maybe as these companies are continuing to grow and build their, build their products, etc., getting into a position where, I mean, let's face it, and I guess we actually did talk about this on your show, but at some point, if you've automated enough, DevOps and some of these things can get boring, right? Like if you've done a good enough job at what you are doing, you've kind of made your job boring.
As
And
you should, as
yeah,
you should. Every good engineer is trying to work themselves out of a job every day. Like
yeah.
honestly, that's where we're at.
But I think we almost have kind of a like a counterbalance there, where we have people that, this is something that we talk about pretty often in our company is, are you adopting the right technologies for your company, or are you adopting the right technology, or are you adopting the technologies that gives your DevOps team a challenge, right? Like do you
Right.
need the complexity of whatever that solution is, or would have something, whatever, obviously I'm biased for cycle, but would the a much more foundational technology get you to where you want to be, without all this extra technical debt? Because like, just like how we talk about with developers with dependencies, when you have, I mean, like, you can look at so many of these tools in the container space or even in the DevOps space as, I mean, really they're still dependencies, they're just not code dependencies. I mean, I guess technically they still are code dependencies, but like I guess the point I'm getting at is tool dependencies, right? Where you end up with this very large stack of different things that you need to piece together, this puzzle of tools, and it's more there to help with job security and to help keep those DevOps teams excited about what they're doing, as opposed to reaching the point that I think we both talked about of ultimate automation. And so it's just one of those things that I spend a lot of time thinking about is how can we make that easier to
Right.
for these companies to adopt.
I think too. This speaks to a little bit of a larger point, but I think that you're onto something where you're saying tools can be like fashion. That that's why I'm saying we have tons of fashion in IT. We have the if you want to look at the latest fashion, you go look at the Stack Overflow surveys every year of developers, and that list is basically the top 10 of fashion, right? In dev and tech, because we all have a gluttony of choice now. I think there's some really good older uh, engineers that talk about, in the 70s and 80s, there was only a few programming languages. One person could actually learn them all the major languages you could know because you could fit them on one hand. And now we have gluttony of choice everywhere at every level of your decision matrix. From the bottom, what languages do we use and support, to how do we manage this project? What tools do we use to manage the human ideas and the workflow? Like there's so many levels of choice. And it's infinite. It's just really is. And that is in and of itself almost a job role to navigate the choice of all the different tools at all the different levels. And that choice is not something that humans are good at. We're not used to having 1,000 choices and then having to pick one.
Yeah.
It's just not innate in our human nature. So I think that obviously it's hard to talk about right choices. I mean, I'm very biased to containers. I think it's probably the best idea we've had in 10 years of how do I implement business ideas faster in technology. The answer to me is the container needs to be a fundamental part of that, which is why when you talk about the CNCF and these other bodies, the Linux Foundation and whatnot, these are sort of the sole the entire realm of computing minds are sort of collaborating on all these ideas. And the assumption nowadays on all of them is most of the time you're probably in a container. Like you should be. Almost all the CNCF tools assume you're in containers at this point, which they don't really state that because it's almost obvious when you start looking at all the tooling. You don't have to do containers, but you probably should be. And I think that all, again, it comes down to how fast can your business operate. The level of learning that we should not understate is the learning is one of the hardest parts here, because if you have one person in your team that's the avid learner, right, the one that goes home at night and reads books, and the one that stays over or works at home on the weekend and they have a closet in their home and they're tooling around with all this stuff, they're often the one showing up with new ideas. But if you don't have a culture where everyone is learning. And I'm not saying on their personal time, but implement it as a part of your business processes. I used to run a team where I was mandating 4 hours of quiet time study every week, and then the next week you were doing a lunch and learn on that topic. So it was happening. So someone every week was getting picked to teach the others what they learned in 4 hours on a Friday. And Fridays are good because like everybody's just sort of already checking out anyway. So we would do 4 hours of learning. You probably hopefully should already know what you're going to be learning. And then one of you on Monday, and this is sort of a challenge I would do. I wouldn't tell them who I was going to pick. And so on Monday I would say, okay, so and so, you teach us what you learned Friday. On Wednesday, we're just going to do like a 30-minute lunch and learn thing. And if you don't have, I find that if you don't have that culture of learning and sort of institutionalizing the learning process and teaching others, not everybody's going to be great at it, and that's totally fine. But if you don't do that, what you end up with often is that one person who's always like, hey, I've heard about containers. Hey, I've heard about serverless. Hey, I've heard about this orchestrator, that orchestrator, this new tool. And the problem is since no one else is paying attention, no one else is learning from them, so their ideas are often the one that gets implemented. Or, there's not a lot of people to validate or invalidate whether their idea is good or not, because no one else is learning new stuff. No one else is reading or going to conferences. And so I often try to look at teams and say, if I look at their technology stack and I look at their automation and I look at how they're doing things, and I say, I can kind of see to myself, yeah, they're really not optimized for speed. They're stuck in a lot of these different human gates, as we call them, where they have to wait for someone to do this part and wait for someone else to do this part, and only this person can deploy to the servers or whatever. And they really need to optimize their team in order to get better productivity. I start to find often, in fact, I probably should start tracking this because it's so common that I start to wonder if it's a key indicator that if your technology teams aren't making the learning and sharing of knowledge a foundational part of the team's infrastructure or the team itself, then you're going to end up in these weird loops where you're adopting the faddish tool that doesn't actually make you better as a team. And by better, I mean faster. Yep. So I do think that there is a problem there that we need to solve as humans and figure out how do we conceptualize the fact that there are now, 3+ container runtimes when 9 years ago we had Docker. Now we've got 3 or more. So it just that one decision becomes problematic if nobody's learning. So
yeah, and as we talk about learning, obviously you have your courses and things like that, and so for people who might be watching this podcast or listening to it, and maybe they have an entry level knowledge of containers or some of these DevOps tools, or but they want to deepen their knowledge into those areas. If those people are interested in taking your courses and stuff, how can they get involved with that? And
yeah, you can find me at bretfisher.com. That's 1 T in Bret, no C in Fisher. So it's like the opposite of what some people type. But you should be able to just Google that and Docker, and hopefully it'll send you to me pretty quickly. Bretfisher.com is where you can find most things. I have a podcast, I have a newsletter, I have a weekly live show on YouTube. We have courses all on Udemy. So if you're in a company that's lucky enough to buy Udemy Business, which is sort of the all you can learn plan for every company employee, like big companies like IBM and eBay do it, then you already have access to all my courses actually, and any new courses I have, because those all go into that program. So, but yeah, you can get coupons, links, discount codes, all that stuff at bretfisher.com.
Excellent. Well, Bret, it's been phenomenal to have you on the podcast. Really enjoyed our conversation. I think we've talked about a number of things that sometimes go non-discussed. People get, I think, so into the weeds, as like we started talking about with the beginning of this podcast. Some people get so into the weeds with the underlying tech, where it's I want A versus B, and I can make a pros and cons list for each of those. The underlying reasons why we're making a lot of these decisions and this advancement that we've seen in our companies has not gotten the attention that it deserves. So it's been great having you on the podcast. Have really enjoyed this conversation and really looking forward to the next one. As we wrap up, is there any other links that you'd like to share with our audience?
You can join me. You can join me live every week on YouTube on Thursdays at Bret.live, and Yeah, I hope to see you around. We also have a Discord server with 10,000 DevOps professionals. You can do that at devops.fan. Yeah, I could send you links all day, but just show up on our live show or show up at the Discord. We'll help you out. We'll find you what you need and see what we can do. So thanks, Jake.
Perfect. Sounds good. All right. Thanks so much, Brett.